Okay, part 2 we come. Fast and furious. See how much I can try to get done.
Like who? And she was like fat. I was like, oh. So just
All right, make sure I've got my calculator.
Fat. Shit. Fat.
that's what my family calls her.
That's all.
Just fat.
All right, 51. Balance the equation. Now listen, they said using smallest whole number coefficients. Okay, so you gotta listen to how they want you to answer the questions here. So balance the small numbers. Let's go to your answer booklet, like that, and let's balance a little hearts away. Okay, and let's see here. All right, so there's many ways to do this. Obviously, it's a little puzzle. 5 carbons. Only place on this side with carbons, I put a 5 here. Okay, there are 12 H's. Only place on this side of H's is here. To make 12, I put a 6 in front. Both sides have the same number. Now this gives me 6 oxygens, 6 times 1, right? And this gives me 5 times 2, 10 oxygens, right? So this gives me a total of 16 oxygens on my product side. So I need 16 oxygens here. What times 2 is 16? 8. Put a 1 there if you like, but left it alone, it's fine. Lowest whole number. So if you got 2, 16, 10, 12, you have to reduce. That's all they want there. My gosh. 52A. Let's get rid of this. Okay. In your answer, in using your balance equation, show a correct numerical setup for calculating the total number of moles of H2O produced when 5 moles of O2 are consumed. So we have 5 moles of O2 and total number of moles produced of water from 5 oxygens. So they're giving you 5 oxygens and they want water. So I give my 5 oxygens, 5 moles of O2. Now, they want water. My friends in chemistry, I'm going to get rid of O2. Where does O2 go? Algebraically, it goes on the bottom. And I want water. See, this is a stoichiometric problem. They give you information about one chemical, and they want you to answer about another. Look at the ratio. I'm sorry, the information they gave you was for O2. It's an 8 to 6 ratio. Okay, so look at the balance coefficients. There are 8 oxygens to how many waters? 6. That's my answer. That's all I have to do. Now you could do this an easier way maybe. Okay? Here's how you could have done it also for those that struggle with the math. They gave me 5 O2. So I put the 5 over the O2. They wanted something about the water, so X over the water. What's the coefficient in front of the O2? 8. 8 becomes your denominator. What's the coefficient in front of the water? 6. And there's your answer. 5 over 8 equals X over 6. They just wanted the setup. Okay, whether you put units and make it nice, this is nice chemistry here gets the answer. Doesn't matter to me at this point. Okay, this is the setup. We take either one. Okay, there's many ways to come up with this right answer. If they want the answer, you just 5 times 6 divided by 8, you'd be good to go solo. Okay, so let's go back to the question, 53. In your answer booklet, okay, record the electronegativity for the elements with atomic numbers 11 through 7. Are you kidding me? I just want you to read off table 8. I'm not going to do that. Okay? No, 52B, where am I? Where was I? 52B. Oh, I didn't read, okay, record your answer, sorry. Okay, so what did we get? 3.75, and there's no sig figs answered for them. So you could have put 3.8, don't worry. If they said significant figures counted, you'd do that. So I'm sorry, so moving forward. Next question. They want you to go to table S. And they didn't tell you that, but table S gives you those. I'm not going to do that. Okay, you can plug those in for the atomic numbers. I mean, that's just, you know, really? Okay, they give you a point for that. And then on the grid, on your answer, mark an appropriate scale. I'm not going to graph that in front of you, and that's a point. Now, an appropriate scale, I will talk about this, though. An appropriate scale is one that's continuous. Do not do breaks. If you want to start at, I don't know, electronegativity, let's say 1.0, you can do that. But don't start at 0 and do a break. That's not continuous, you'll lose a point. Continuous scale means that, hey, every box equals 1 if you did it like that. Okay? Make it continuous. So that you can see a trend. Because if you do it too tight like I did, maybe the trend, you can't see it. If you can barely see the trend or something it might do, if you see the trend, electronegativity, okay, then you're good. You don't have to use the entire graph. But I have to see a continuous scale that shows me the trend. If your scale is too small and it's flatline, you lose a point. Make it continuous. Okay? Circle to connect the points. Okay, that's a point for that. Wow. All right, so 3 points. That should be 6th grade science, in my opinion. Okay? Didn't even ask questions about it. 56. Here's a blurb. My opinion, go read the question first. So many people try to read these blurbs and get all confused. Identify the solute. Solute, by definition, is a substance being dissolved. Who's being dissolved? I have 200 grams of water, which, by the way, is called the solvent. That's the substance doing the dissolving. I want to saturate a solution with potassium chloride. So who's being dissolved? KCl. That's just it, people. And people say, I can't do part 2s. Are you kidding me? All they wanted you to do was tell me who was being dissolved. Now, if you didn't know, the solute is the substance being dissolved. That's the problem. The water was the solvent. It's the chemical doing the dissolving. Okay? Number 57. According to reference table G, how many grams of KCl must be used to create this saturated solution? Now, hold on to your ponies for a second. When you go to table G is based out of 100 grams of water. They said we're using 200 grams of water. So the information we have on table G has to be adjusted. Okay? Well, if there's twice as much water, there's twice as much solubility. So we have potassium chloride at 60, and they want to prepare a saturated solution. Now, saturated means what? Above the line, on the line, or below the line? On the line. So I'm trying to find how many grams at 60 degrees Celsius for KCl. So let's go there to the reference table. Okay, we're looking for at 60. Table Gorodsky. Egocentric that I am. Okay. So let's go find KCl. I know it's kind of small for some of you. Feel bad, but now I'm over it. So there's KCl. Okay, let's make it bigger because it's too small for my eyes. So there's our KCl. At 60 degrees Celsius, they said saturated. I'm on the line. I read across. Approximately 45 grams of KCl added to 100 grams of water at 60 is saturated. But I know a lot of people would miss that. They had 200 grams of water. So how much grams is it? 90. That was a slippery one. I had it double by 2 because the water was, what, twice as much. So that was 90 grams. Now that would give you plus or minus probably 2 or 3 there. But approximately 90 grams. I had to times it by 2 because it's twice the number of water. 58. Okay? This solution is cooled to 10 degrees. And the excess KCl precipitates out. The resulting solution is saturated at 10. How many grams precipitated out? Okay, well, let's go there. So it was cooled to 10, and now it's still saturated. Well, how many grams from this position above the line to that position? 10 plus 5, I'm guessing. But my friends in chemistry, that's 15 in what? 100. And 200, that's third. Again, very slippery there. You're above the line as it cools. You're saturated as the solubility drops. Now you're above the line. So 30 is the answer. Oops. Approximately. Maybe plus or minus something. 59. Ooh, voltaic cell. Love it. Okay, first thing I do when I look at these is who's the anode? How do I know? The first time I look at these, I say, who's the anode? Anode is an-ox. Who's the anode? Who is higher on table J? Pb is higher than silver. That means in a chemical reactivity series, lead is more reactive. This metal is better at oxidizing. So this is my anode. This must be my cathode. Does everyone understand that Pb is higher on table J? Good. Electrons flow from what to what always? Always from the one who gives off electrons to the one who accepts. Why? Because Leo, losing electrons is oxidation. So this one loses, and gaining electrons reduction. So you have to go from the loser to the gainer. Only way. Okay, let's go to the question. Now, by the way, if you still don't know that lead was the best at oxidizing, look at the overall reaction, party people. Look at the overall. They always are going to give you an overall reaction. Who can only oxidize? The standalone what? Metal. Metals that are atoms can only lose electrons. So this had to be the anode, and this one had to reduce. You never pick from this side. Okay. When a switch is closed, which half cell does oxidation occur? Oxidation anox is the lead half cell. You can say the lead half cell. Anox, where the anode is. Why? Because the standalone metal is getting oxidized. Its charge is going up because it's losing electrons to the side it's gaining. So you could say the left side, you could say the one with the lead. Okay, very simple. So the left cell, the one that has the lead, works for me. It's the one that gets oxidized. When the switch is closed, state the direction. It's always, so it's going to go from left to right, from the anode to the what? Cathode. Through the wire, people, never through the salt bridge. If electrons could flow through the salt bridge, there'd be no charge. So what goes through the salt bridge is the ions. Okay? And what does the salt bridge do again? It allows the movement of ions or maintains electrical neutrality. That's all good for me. So back to the question. What did I say here? Directions flow from left to right. So left to right, anode from the Pb to the silver. You can say that as well. Notice it's from electrode to electrode, never through the solution. Okay, 61. Based on the given equation, write a balanced half reaction that occurs in half cell 1. Oh, they even named it. Half cell 1. Half cell 1 is the anode, oxidation. Pb0 goes to Pb plus 2. Now, how many electrons were involved here? 2. Where do electrons go so that both sides of a half reaction are the same, or conservation of charge? I put them on the right side. Negative 2 and a plus 2 is 0. This side is 0. This side is 0. And that's your answer, party people. They want you to know the left hand was the oxidation side. So Pb0 goes to Pb plus 2. You leave out the electrons, wrong. You put the electrons on the wrong side, wrong. Both sides have to have the same charge, 62. Draw a Lewis dot diagram for an atom of phosphorus. Wow, really? Now phosphorus is P, not K. And if you go to the reference table, which is a good place to start to know its valence electrons, because valence electrons are those electrons available for bonding. So you've got to draw the number of dots that represent valence. That's the key here. So P 2-8-5 has 5 valence. 5 dots. You do not draw the dots for the other electrons. These electrons are called kernel electrons. They're not available, so only 5 dots. That's all they wanted. Very simple. So I count, I don't care where you put the dots, as long as you have 5. Now, if they wanted P negative 3, you'd have to add 8, because it gained 3. Okay. So moving forward. All right, moving forward, oh, here comes the blurbs. Part C's. Guess what? You can do what you like, but I tend to say go right to the question. Identify the two gases. Well, these are what? Spectral lines. You guys did this. Who is responsible for this line? Hey, gas A, gas A, gas A. Who's responsible for this? Who's responsible for this line? Gas D. So you say A and D. You guys did this in class with the gas discharge tubes. Okay? Explain the production. I love this question. It's on almost in every Regents. Explain the production of the emission spectrum. My friends in chemistry. Electrons that are what? Excited. Jump what? Back. Closer to the nucleus, or you could say what? Or, in fact, or to this ground state, and give off light. Oh, you can stop there. Electrons that jump back toward the nucleus, right? Here's your nucleus. Here's your shells of electrons. Electrons gain energy, they jump farther away. Now they're excited with high energy. Well, they give off the energy when they jump back in the form of light. So you need to explain that way, and this seems to be on many tests. Okay? Electrons jump back closer to the nucleus. That's all you need, and they give off light. Moving forward. Wow, all that stuff in front I did not need. It's amazing. Same thing here. Go right to the question. Which sample will represent a pure substance? My friends, a pure substance is an element or a compound. A pure substance is not a mixture. A mixture is made up of two or more substances. So this is a mixture. This is a mixture made up of two or more substances. One substance, one element. Sample 3. 66. When two atoms of Y, okay, Y is the dark ones, and one atom of Z, the light ones, of compound form. Using the number of atoms shown in sample 2, what's the maximum number of molecules of this compound? So when two atoms of Y react, okay, yes, using the number of atoms shown in sample 2. Okay, so using sample 2. So they're going to say what? One black and two what? So one black, got rid of that one. Two atoms of Y, yep, thank you. Two blacks and one white, that give me that guy. Then I take two blacks and one white, two blacks, one white, okay, and then I'm done, aren't I? What's the maximum number of molecules this compound can be formed? 2. The rest is, I don't have enough blacks to keep going. Explain why excess does not represent a compound. The same what? Element bonded to itself. So you just say what? Same element. Same atoms. Many ways to skin a cat here. Compounds are what? Two or more different atoms. Come on, people. What's so hard about these part 2s? These questions could be twisted as multiple choice questions. People get lazy and don't feel like answering. Think with me. These are the same concepts we just covered. Number 70. What is this organic reaction? Now, this one you're going to have to know. We talked about this a lot. Organic acid plus an alcohol. You know what comes out? The water comes out. So, 2 H's and an O. So the water comes out. That's what this is. And you push this together. If you don't know what this is an R, the rest of an organic compound. C double bonded O, O to a what? Another R. This is an ester. If you go to table R, you'll see that's an ester. Okay? So guess what? This is esterification. Not a lot of wiggle room here. Making an ester is esterification, one of the important ones. What compound, organic compound is this with an OH? Who is in table R, an R with an OH? Now what does the R represent? The rest of an organic compound, hydrocarbon and an OH. This is an alcohol. It's right from table R. And then they want an isomer of reactant 2. What does that mean? Yeah, just make sure you have the same number of stuff. So I have 3 carbons. I'm going to put the OH in the middle. Same number of stuff, and there I'm done. If you want to put the H's at the end, you can. You can leave it like that. Now you could have drawn probably an ether or something else, but that's an easy way. Different structures, same number of stuff. Come on. Okay. Oh my gosh. This blurb, there's so much information. Guess what? I suggest, and this is just me, go to the question. Write the equation for alpha decay that occurs in the smoke detector containing americurium-241. Now they gave you 2 points for this. Now, americurium's not listed, is it? So, what do they say here? They go back. Alpha particles are emitted by americurium-241. Let's go to the reference to the table here. So americurium-241. What number was it? So americurium-271. Okay, I go to my periodic table. Okay, they give you 2 points for this. Now americurium is on the bottom. Where are you, AM? Yep, thank you. And 243. Doesn't really matter. It's atomic number 95. They give you a different isotope. Doesn't matter. So 95 protons what we're using. So I put a 95 here. What was the number? 270 what? 271. In their reading they said alpha particles are emitted. Alpha particles are helium nucleus, 4/2. If you do not know, table O shows you what this particle is. So I got that alpha particles are emitted. Guess what? Here's how we do this, party people. What number plus 4 is 271? Did I say 241? Okay, sorry. 241. What number plus 4 is 241? 237. What number plus 2 is 95? 93. Who's atomic number 93? Neptunium. That's 2 points. 2 points right there. They're going to give you a point probably for the correct element, and then for the right numbers here. This is a 2-point question. You need to be able to write nuclear equations. 72. If you have to leave, great, I'm going to keep going. It's not rude if you have to go. 72. What's the radioactive decay of krypton-85 different from the radioactive decay of americurium-241? All right. Krypton-85 might be in the reading, so I go back. Don't see it. Okay. So let's go to table N. Krypton-85. So I go to table N. That should list me my krypton. 85. There it is.
Krypton 85
It is right there. So it's a B negative. Now a B negative, what the heck is that, Mr. Grodsky? Well, go to table O, okay, if you're from Brooklyn. And table O, my friend, okay, tells you that a B negative is a beta particle. That's all they wanted. That question was looking up where? Using table N. So beta particle, or you could write this, B negative or beta particle. Really? So that all that reading was really, all of this, like cloak and dagger stuff, read the what? Table N was all that was. State one benefit or useful application of radioactivity not mentioned in this article. All right, well, they give me electric blankets, fluorescent lights, even food we eat is radioactive, the more rich, okay, makes about 10%. So how about one benefit of how about cleaning utensils? Okay, a lot of restaurants use radioactive particles. They talk about smoke detectors we can't talk about. So that's one not mentioned. What other benefits can you think of? Possibly you could talk about energy. We can get energy from these. So anything that makes halfway decent sense that's not listed here. Okay. We can use, well, there's another big benefit I just remembered. My brain went to sleep on me. What about using for medicine? Right? Don't we use nuclear radioactive elements with short half-lives for medical tracers? So that's another big one there. 75. I'm gonna go right to the question because some people. What's that? Oh, a risk. Sorry. I was stuck on 73. I didn't see 74. So 73 state one benefit. I was answering 73. 74 states one risk or danger associated with activity. Cancer, you know, sickness, death and destruction, meltdowns. I mean, you know, you can list any of those. These types of questions, I'll take any answer that makes halfway decent sense. Don't get lazy and say banana daiquiri or something. Doesn't make any sense. Okay, 75. Oh my gosh, I'm tired. I read the blurb. I don't know what gypsum is. What do they want? Go to the question. They want the gram formula mass of this. What does that mean? Just add up the what? Add them all up. I got 1 calcium. 1 times 40, it's the atomic mass of 40. Do the math, it's 40. I've got 1 sulfur. 1 times 32. 32 is the atomic mass of sulfur. 32. 4 oxygens. 4 times 16. 64. Now, I'm going to cheat here. I know water is 18 apiece, right? It's a 16 plus 1 plus 1. So times by 2 is 36. So I'm adding everything up. When you add everything up, on the top of my head, I'll make this wrong. So 40 plus 32 plus 64, as we said, no head, plus 36. I get 172. That's all they want you to do. Forget the blurb. The blurb's got nothing to do with it. Okay, people get intimidated. My gosh, that's a part 1 question. Okay. Now, and sometimes they want the work and for 2 questions. Now, this one's just 1. 76. In the space provided in your booklet, show a correct numerical setup for calculating the percent composition of mass in water. Really? Percent composition is what? Part over what? Total. And if you don't know this, party people, okay, if we go to our reference tables, on table T, it reminds us that. Let's take a walk to table T here, and look what they put here, party people. Percent composition, mass of part, mass of total times 100. So, back to this. So here's the work I need. What are they asking for? Percent by mass of water. So 36 the total mass of water over the part. The part is 172 times 100, and that gives you a point. They didn't want the answer. Oh, 1 point for the work, right? And they do want the answer for B. Okay, so 36 divided by 172 gives me times 100, 21%. 2 points for that. Show me that's difficult. Okay, maybe you forgot that a formula mass is the mass of the formula. Maybe you forgot to look then. But by reviewing many questions, you can see all of these questions are multiple choice fair game as well. Moving further. Oh, a potential energy curve. I'm going to go right to the question. Which lettered interval in a diagram represents the potential energy of the products? These are my products. These are my reactants. I start here, I end here. So this is the energy of my products. D. That could be a multiple choice question. What is B, by the way, since we're here? The guy who lives at the top of the hill, called the activated complex. Right. What's C? The difference of where I start and where I finish. What's that? Delta H. Notice it's going up. Therefore, delta H is positive. Okay? So, which letter in the represents the heat of reaction? Heat of reaction is delta H. That'd be C. Wow, really? That could be a multiple choice question. Identify a reactant listed in table I. Now, here we go. That could be mixed with water for use in a chemical cold pack. This is a great question. If it's going to make a chemical cold pack, that means the environment's getting colder or warmer?
Colder.
Colder. Do endothermic reactions or exothermic reactions make the environment colder? No. No. Here's the reason. If I have something endo in my container, endo, we know, absorb energy, right? So if I've got water, energy flows from the water into the endothermic reaction. An ice cube going from a solid to a liquid. Doesn't liquid have higher energy? Ice cube melts in your hand because it's endothermic. It's taking energy from your hand to melt. The reason why it makes your, what? drink colder is because it's drawing energy from its environment. Things that are endothermic make the energy colder. So I'm looking for any reaction with table I that when dissolves in water is endothermic. So going to table I, they would accept anything. So let's go to table I. They told you that. Table I, okay?
Like ammonium nitrate.
So they said with water, so there's many choices here. You could have picked, they said what compound, is that the question? So potassium nitrate, look at that. Positive is what? Energy is going where? Starting low, going high. It means it's going up. By the way, if you forget, delta H's are negative for exo, so positive for endo. So I could have used potassium nitrate, I could use ammonium chloride, I could use ammonium nitrate, or NaCl. Any of those compounds, okay, you could have picked would have been the right answer, because when mixed with water, they create an endothermic energy change. They take energy from the environment, making it colder. They use the energy to do something, okay? Rocking on, or easy listening on, okay? La la la. So what do they want actually? They want to identify a reactant, yeah, okay. So based the answers to question 80 and 81 on the information below, I'm going to read the question first. What's a new pH of the soil? Okay, the pH was 5. We talked about this today. And there's a 100-fold decrease in hydronium ion. What the heck is a hydronium ion? What the heck table? So if you forget, I go to the what the heck table, and that's table E. What the heck is that cluster? Hydronium, people, is H3O+, which is synonymous with H+. That's acids that have low pHs. So my friends in chemistry, oops, not that, I don't want that. My pH is 5, and there's a decrease in my acidity. Is the pH going up or down? Yeah, anything that's basic is higher than 7. So if your hydronium ion is decreasing, you're getting more basic, so your pH is going up. The question is, how much? 100-fold? Hey, wait a minute. pH is a logarithmic scale. 10 to the what power is 100? 2. So this is going to go up by 2, and the pH now is a 7. Right? Every movement of a single integer is a 10-time amount, is a 0, base 10. If it was 1,000-fold or 1,000 times decrease in hydronium ion, it's the same thing as saying it's 1,000 times increase in the hydroxide. And that'd be an 8, wouldn't it? 1,000 is 10 to the 3. They love this question. They love to ask, do you understand that? According to table Fufu, number 81. Okay? Yeah, you got to give them little nicknames. They're not like table F has the information. No, table Fufu. It's something you can snuggle and hug. According to reference table F, calcium hydroxide is soluble in water. Identify another hydroxide compound that contains a group 2 element that's also soluble in water. So let's go to table Fufu. Okay, let's get out of this for a second. And let's go to table F. If I know E, F, nope, don't know my alphabet. There we go, it's below it. There's table F. And there's some hydroxides. When combined, let's make this bigger, up close and personal. Well, hydroxides, people, are usually insoluble, except with calcium, barium, and strontium. Now, they've said pick another group 2 element. Is barium and strontium a group 2 element? They are. And if you did not know, since I'm covering all bases, you go to your reference table, your periodic table, and you see that barium and strontium are group 2 elements. So you could have put barium or strontium there. Wow. Really? Really? Come on, people. What's so bad about part 2s? And that's the test, I guess. Yep. All right. So if you want more of this, you want me going over more questions, you go to my faculty website, Brodsky Chemistry, or Grodsky Regents Chemistry, I've got more tests that are videoed, 5, that go over that. If you want to go over a crash course, you want to go over every single periodic table, there's many resources for your viewing displeasure. Okay? So, again, look at, with this, I want to go back. So if I go to my review folder, I've got videos of me doing all of these, every single question, doing it the same way. Actually, I go into more detail because I'm long-winded and tall. I will have today's review session up there as well. And then I have these crash courses for each topic. So please, if you're feeling a little wheezy about this, spend more time with me digitally. Okay? Hope you enjoyed that. Rock on. Good luck. Make sure you bring tomorrow a non-graphing calculator.
Did you grade that